When we are asked to simplify a problem containing a radical along with a division bar, we probably want to begin by reminding ourselves that we're going to use the conjugate of the denominator to rationalize it. Since it is not considered simple to have a radical in denominator, that's our common process. We will emphasize the grouping by drawing parentheses around each the numerator and the denominator, and then writing the radical's conjugate, which is the first term added to the second term, or whatever the reverse sign is, and then keeping in mind that this is only a legal process if we also multiply the numerator by that same expression. Our multiplication then involves this FOILing process, the first times the first, so radical x times radical x. And the conjugate, then, we are reminded that we'll take the outer, which is positive 1 times radical x, plus the inner, which is negative 1 times radical x. And then finally, last times last, which is negative 1. We continue by also multiplying the numerator. X times radical x would be represented. The outer, x times 1. The inner, negative radical x times 1. And finally the last term, negative 1 times positive 1. Continuing with the numerator by combining like terms, we notice there aren't any to combine, so we'll actually have 4 separate quantities in our numerator. The denominator, on the other hand, provides other opportunities. We notice that a square root of x times a square root of x would be itself x. Continuing, and this is the reason we use the conjugate property, is that the term radical x minus radical x causes the radicals to add to 0, and our last term is subtract 1. It is obvious that the denominator is now considerably simplified and no longer contains radicals. This then is the final answer.